Hi everyone. We're going to construct a highway using the law of sines, and we're talking about Highway 41, whose primary directions are north and south. So this would be north, this would be south, and we're in Florida, West Florida. A bay, this bay here, obstructs the straight path of the highway. So the cost of a bridge is prohibitive, so engineers decide to make a road across a highway that goes around the bay. So this is the picture, and the picture actually gives you all this information here. We need to know the length of the highway, so we need to know this length here. So from B to E plus E to D plus D to A, or you can go the other way. So the first thing we're going to do is find alpha and beta. They give you these angles here, the 140 and the 135. So to find alpha is just 180 degrees because we're doing supplementary angle theorem. So minus 140, which is 40 degrees. So this is 40 degrees here, and this is going to get really sloppy. A lot of stuff on here. All right, and then so beta is the same thing, 180 minus 135 degrees, which gives you 95 degrees. No, so beta is going to be 45 degrees. So this is 45 degrees. Therefore, this angle C is gamma is going to be 180 minus 40 degrees. These are all degrees. Minus 45, which equals 95 degrees. Once you have all that, then we're just going to use the law of sines. This is 95 degrees right there. That's your gamma. So basically, the first thing we're going to do is, also this is 1/8 mile, this is 1/8 mile, and 1/8 mile, if you want to convert, equals 0.125. Makes it a little easier when you're using the calculator. So basically what we want to find is the length of BC. So BC is going from here to here. We're using this triangle. And then we're going to find AC. So basically BC is going to be the law of sines. It's going to be sine of 40 over, because that's your 40 here, over BC equals sine of 95 degrees over 2. So you get BC equals 2 sine of 40 over sine of 95, which is approximately 1.290 miles. So that's the length here. We're going to have to subtract. Don't forget, we're going to have to subtract this at the end, because I'm going to have to go to a different slide here. Okay, so for the AC, we're going to do sine of 45 over AC equals sine of 95 over 2. So we get AC equals 2 sine of 45 divided by sine of 95 degrees, which is approximately 1.420 miles. And again, we're going to have to subtract 0.125. So let's go ahead and do that. So BE equals 1.290 minus 0.125. Again, we're subtracting this extra. We had to make a triangle to do this, so we have to subtract it back out. That part right there. All right, so that's going to be 1.0 0.165 miles, and the length of AD equals 1.420 minus 0.125, which equals 1.295 miles. Okay, so for our isosceles triangle, we have the angle of CDE equals the angle of CED, because this is an isosceles triangle. So right here, these should be the same. Okay, so basically, we're going to get this equals 180 degrees minus 95 divided by 2, which equals 42.5 degrees. So now we can find DE. So DE is going to be, how we do that, we're going to do sine of 95 degrees over DE equals sine of 42. We're setting up similar things here. Sine of 42.5 over 0.125. We have to find the length of DE. And when you cross multiply and everything, you're going to get 0.184 miles. All right. Now, so now we have to add everything up. So just remember what DE is. DE is this part here. All right. Now we just have to add AD plus DE. Let me do a different color. Do we have any colors? Let's do purple. We defined the length of AD, which we already know, the length of DE, which we already know, plus the length of BE. So we're going to do that, and we get AD plus DE plus BE equals 1.295 plus 0.184 plus 1.165, which is approximately 2.64 miles. So the approximate length of the highway is 2.64 miles. Thank you and have a nice day. Bye-bye.